Hello guys, welcome to today's gaseous exchange exam practice screencast. So the focus of this is not going to be to go through exactly how you, I suppose, understand gaseous exchange. This is probably the last process you would use in the lead up to exams, whether that be kind of end of unit exams, mock exams, or the summer A-level exams. So the idea is that I will give you a little bit of clue, or the odd clue to help you answer the questions, but ultimately it's going to be a little bit of an introduction. I'm going to give you an exam question. I might give you a little tip on how you might answer it. Then you must pause the screencast so that you can have a go at answering it, and then I will talk you through the answers and the mark scheme after. Okay, so in terms of gaseous exchange, so what are we going to go through in this session? So we're going to have a look at exam questions that are linked to gaseous exchange at the alveolar muscles during rest, same during exercise, and then we're going to have a look at that bit at the end, which is the changes in the dissociation of oxyhemoglobin during exercise. Okay, so that's our three sections. If we just very quickly have a look through where we've been so far then, so we've had a look, so just an overview to say that we've looked at gaseous exchange at rest and exercise. That's what we've looked at. Okay, we've looked at two gases, oxygen and carbon dioxide, looked at two sites, alveoli and blood and muscles. So we've looked at getting gases from here to here and here to here. I've looked at getting gases from here to here and from here to here. Okay, now in order to answer questions, we kind of went through a bit of a focus. In order to get marks, we had to go through this. We had to talk about the rule of diffusion. We had to talk about the partial pressures where a gas is high, where it's low, and then that would lead to a diffusion gradient, which would then lead to diffusion. So obviously you don't need to copy any of this down at the moment. What I would say now is I am going to give you, on this next slide, a way that you can use to remember and I suppose to act as an exam answer framework for anything based on gaseous exchange. So that's what I will ask you to write now from now on. Okay, so this now, your section is going to be called Memory Method to Answer Exam Questions of Gas Exchange, and it can be used during rest and exercise. So let's have a look what it is then. So ideally, when you get a question, the question's going to say the words gas and exchange. Okay, when you see a question that says gaseous exchange, it's really important you have a framework to make sure you are writing the correct words. I have no doubt that a high number of people understand the process of diffusion of gases move from an area of high pressure or concentration to low pressure or concentration. However, you have to show certain bits of terminology in order to make sure you maximize your exam score in the exam. And that, unfortunately, is education. Okay, there's no point having it in your head if you can't get it onto paper. This is just now. This is your margin. Okay, so when an exam question comes up, what I'm going to take you through now should be in your margin. Okay, and I'm going to give you a couple of chances to practice this with exam questions in the screencast. So when we see a question of gaseous exchange then, okay, so the first thing we would think about when we see gaseous exchange is we would see the gas, the content qualifier here is gas, so we put gas into here and we turn the word gas into GASP. We might take a gasp of oxygen to start gaseous exchange off. GASP DD. Okay, so that is going to be our memory method. GASP DD, as always, when we use a memory method, that is going from the content qualifier. That is creating the new word. The new word is going to be margined so that we can then use it to tick off and make sure we've answered the question correctly to the right level. Okay, so if we go from here then, what does it mean? Well, the first thing you have to do in the first two parts of this acronym, the G and the A, are not actually things you would ever put into an exam. They are more the bits that you would highlight on an exam question, or you could call them thinking questions, so you're setting the scene correctly to answer a question on gaseous exchange. So what do I mean? So first thing you have to work out from an exam question is what gas is it asking for? Is it asking for oxygen? Is it asking about carbon dioxide? Or if it just says the word gas, it's going to be both gases. So sometimes it'll give you one, sometimes it'll give you the other times it'll just say the word gas exchange, therefore you've got to put both. So next thing we have to work out from the exam question to stop us from getting into trouble and answering the wrong way would be the area of which the question is asking about. So the site, really, the area or site. Using area because of the acronym. So the area will either be the alveoli and blood or the blood and muscles. It always has to have the blood, okay? because that is the part that allows the gases to exchange and move. Okay, so that is really important in there. Now, once we've got those two thinking questions, now we're into anything below this line is where we start to get our marks. So the first thing we're going to do is we have to make sure we give the rule of diffusion. Now, because this is so important, I'm going to give it a little, I suppose, a little bit of an emphasis, and we're going to call it special rule of diffusion. So as we know, the rule of diffusion, in this case the special rule of diffusion, is that gases move from an area of high partial pressure to low partial pressure, or high concentration to low concentration. Let's use partial pressure because that's what's going to be in our answer. Okay, so once we know that, then I think once we've got this, you always get a mark for that, believe it or not. Any gaseous exchange question I've seen on a mark scheme, it always has a mark for you, even without giving it context. It's just saying gases move from an area of high partial pressure to low partial pressure. I think it's a brilliant way to start the answer, because the next thing you have to do is you have to then explain with context where the partial pressure of the gas is high and where it's low. So the next part on our acronym is partial pressure. So we have to say under here, where is the gas in question high partial pressure? Is it the alveoli or is it the blood, or vice versa? Where is the gas low partial pressure? Same as I just said before. So that is something we always have to do, and we have to say where it's a high pp and where the gas is a low pp. Okay, so that's our section there. Now we're right into the answer. So we will be getting 1 mark, 2 mark, 3 marks. Now once we know that there is a kind of where the gas is high pressure and low pressure, that creates something called a diffusion gradient. So the distance, or the kind of, I suppose, the gradient being from high to low. Okay, so once we know the difference between the high partial pressure and low partial pressure, this is called a diffusion gradient, and we have to link that to the gas. And then on top of that, we go to our next bit. Once we have a diffusion gradient of a gas, this means diffusion happens, because we know, if we know the difference between the high partial pressure and low partial pressure, we know that diffusion is the process of gas, but this time we give it context. Oxygen or carbon dioxide diffuses from where it's high pp to low pp. Okay, so the process, GASP DD, gas area, special rule of diffusion, partial pressure, where's it high, partial pressure, where's it low of the gas, that creates that gas diffusion gradient. So the gas then diffuses from the high partial pressure point to the low partial pressure, but we have to say where it was high, where it was low. So if that's the introduction, now what I wanted you to do is get that down. You can practice that going up towards the exams. But now what I need you to do is have a look at some exam questions and how we might put that into practice. So I'm going to model one. After I've modelled one, I'm going to ask you to have a go, and we'll have a look at the mark schemes each time. So let's have a look at the first one then. So we're going to start off with gaseous exchange at the alveoli and the muscle tissue during rest. So that's going to be our first focus. So the first question we got here then is describe the process of gaseous exchange of carbon dioxide at the alveoli during rest. Okay, so when we see that question there, what we have to do then, I mean, you've got a choice now. If you want to pause it, you can pause it. If you want to listen to me or watch me model one first and then have a go after, that's absolutely fine. So if you feel like you can do this, you crack on. If not, maybe just watch this one and then have a go at the next question. So straight away, I'm looking here. So I've kind of, if I was in an exam, I'd have highlighted this. So I've got gaseous exchange, that tells me what I'm using as an acronym. Then I've got the gas here, which is carbon dioxide. Okay, following that, I can see where it is, alveoli. So but I can't just say alveoli because it's got to be the alveoli and blood. Now, once I've done that, I've then got to give a generic definition of diffusion. So the special rule of diffusion proposes a gas is diffused from an area of high partial pressure to low partial pressure. Now, once I've said that, it sets the scene, because now I've got to work out where CO2 has a high pp and a low pp, alveoli or blood. So I know that there is a high pp CO2 in the blood and a low pp CO2 in the alveoli. So because of that, the difference between high and low, this causes a carbon dioxide diffusion gradient. Now, because of this carbon dioxide diffusion gradient, I know that carbon dioxide diffuses from the blood to the alveoli, and then we can breathe it out. Okay, so that is how the process happens. Hopefully you can see how I've done that in terms of modelling it. So now if I could just move that across to what I'm going to do here now. So if that's that one, what I want you to do now, I'm going to put the next question on the slide. Can I ask you to pause it and have a go at answering it? So here's the question, gaseous exchange. So you're looking here, describe the process of gaseous exchange of oxygen at the alveoli during rest. Okay, so that is your focus there. So can you pause it now, please? So your job is to pause, and your job now, can you have a go at doing that using the GASP DD process. So if I just go back onto that, see if you can do that, then I'll just go onto this now. So in terms of answering that, you can see onto here, so this time the gas was oxygen, won't be in the mark scheme, the area won't be in the mark scheme, but as you can see, the key bits we need, it's got the special rule of diffusion here, gases move from an area high pressure to low pressure, then it comes into the P's, so I'll put it down into here. There's a high partial pressure of oxygen in the alveoli, there is a low partial pressure of oxygen in the blood. This causes an oxygen diffusion gradient, okay, which then causes, and they did it up here, the diffusion, oxygen diffuses from the alveoli into the blood. I like to do that at the end because I think it's a process, it's hierarchical, okay, so hopefully you've seen that, hopefully that's okay, and we can move it through from there. Okay, so if that's our first one there, let's have a look at the next one. So we've looked at the alveoli and blood, now we need to look at the muscle tissue. So if I could just get you to have a go at this. So what we've got here, same thing. Now with this one, I'm going to start you off. So this question says, perform at rest, explain gaseous exchange between the blood and muscle tissue. Okay, so in this case, it hasn't said oxygen and it hasn't said carbon dioxide. So what we have to do now is we're now talking about the blood and muscle. So what we have to do is make sure that we talk about both gases. So we've got to make sure that we have the O, or O2, and then the CO2. We've got oxygen, got carbon dioxide. Now in this case, we obviously now need to look at our areas, okay, which I'll let you do. But on top of here, I just wanted to make this point before you start. When you talk about the special rule, you're only going to get 1 mark for talking about the special rule of diffusion. So you don't need to write it for both gases. You just need to write it maybe for one gas, and then you will get the mark for that after your generic explanation of the special rule of diffusion. And then your job is to work out where the partial pressure, I'm not going to say no more. You've had your model. Your job now is to see between the blood and muscle tissue, can you work out what is what at rest. Okay, pause now. Your job is to have a go, and I'm going to put it onto the next slide. Okay. Right, so let's have a look onto this one then. So if you can see on your answer here, this is what they've done. So they've got the special rule of diffusion. They give a mark for that at the top, straight in. Okay, so hopefully you've put that somewhere. The next bit is you then need to split your gases up. So you've got oxygen here, and what they've done there is talked about, right, oxygen, high PPO2 in the blood, so low PPO2 in the muscle. This causes oxygen diffusion gradient, so oxygen diffuses from the blood into the muscle. And the flip side to that, because oxygen we've done, carbon dioxide onto here, high PPCO2 in the muscle, low PPCO2 in the blood, CO2 diffusion gradient, which causes carbon dioxide to diffuse from where it's high, the muscle, to where it's low, the blood. Okay, and you can see how that might work. So as we go through from there then, that is our section done on rest. There, yeah, your practice questions. You can go back through the screencast as many times as you want, just to check yourself, pause it at the right times. So if we move on then now, our next focus is going to be having a look at gaseous exchange at the alveoli and muscle tissue during exercise. Now, when you're looking at gaseous exchange during exercise, remember we have to kind of think about things here. So it's still alveoli and blood and muscle. It still uses the GASP DD process, but the key thing when we see the word exercise, as with all of the respiratory system, we have to remember that we have to exaggerate. Okay, and the key thing that we have to exaggerate when we're talking about gaseous exchange during exercise is we have to exaggerate where the partial pressure is higher of a gas. Now, when we're looking at the alveoli or the muscle, there is either the blood and muscle or the alveoli and blood. One of those two, out of the two, is always going to be exaggerated. And if we can work out at what part, or what site, I suppose, that it's higher or lower, we are then able to move through the question easier. So GASP DD, we have to remember to exaggerate. What do we exaggerate? We have to work out where the partial pressure of a gas is higher or lower, and then where. Once we've done that, that will tell us that we have a diffusion gradient that is steeper. Okay, so once we've got a diffusion gradient that is steeper, that then allows us to know that diffusion is going to take place, well, there's going to be more diffusion, it's going to take place faster. So those things there remind us that because of a partial pressure being exaggerated at one of the points, we then have to move through with a steeper diffusion gradient and faster or more of the gas diffusion. Okay, so that's what we're looking at now. It's just how you would change it into your revision notes. If we move on from there then, could I ask you to have a go at this exam question? You've already done the first one, okay, but could I ask you to have a go at it and then see how you would do it differently down to here? All I'm going to do is give you that. what you have to do is see if you can work out how you would answer that. Part 1, oxygen, alveoli and blood. There we go, straight down. When it comes to exercise, how does it change? Do we know where we exaggerate? The partial pressure. Do we know what happens to the diffusion gradient? Do we know what happens to the diffusion? Can you pause now, please? And we'll move on from that. Okay, so if you have a look onto here, you should be able to see the answers here. So you've seen that one before, and as you can see here, there is a lower partial pressure of oxygen in the blood, and then you've got the same, because all the oxygen was used up at the muscle when it's diffused in, so there's a lower partial pressure of oxygen in the blood. There is the same, or there's just a high partial pressure of oxygen in the alveoli. This causes an increased diffusion gradient. I use the word steeper because I like to imagine that steepness going, the gradient, and then this causes more oxygen to diffuse faster. The rate there would be faster. Okay, so hopefully you can see how that would work. No mention of CO2 in this one. If we move on from there then, next bit. Okay, so from here, next question we're going to have a look at. Last topic is the changes in dissociation of oxyhemoglobin during exercise. So when this question comes up, it's a very specific question, although you would obviously get credit for your understanding of oxygen and carbon dioxide diffusion gradients during exercise. Okay, but there is some additional stuff we have to remember here. So when this question comes up, so what I'm going to ask you to do is I'm going to help you on the first one, okay, and see what you can remember. So explain why we see here oxygen dissociates. Why does more oxygen dissociate from the blood into the muscle tissue during exercise? Now on here, I asked you when you see oxyhemoglobin dissociation, when you see that, you have got to make sure that you understand there is a new way of doing this. So if I went through from here, what does that mean? When you see muscle and exercise linked to oxyhemoglobin dissociation, you remember that muscle X Mex. So from there we use Mexican, and we remember our favorite Mexican restaurant, Dr. Taco. Okay, so Dr. Taco turns into DCR Taco, and then if you can remember what they stand for, that will allow you. Now what I'm going to say to you is you should start your question by repeating. I don't ask you to do this very often, but you must remember that more oxygen dissociates from the blood into the muscles because if you put that, you would get a mark. If you then were specific, you can't just put the words for these. You've got to say, when you write the words down, what happens to them and where. It's no good just saying there is an increase of it. You need to say an increase of it where. Okay, and then obviously the other bits are a little bit more simple. Okay, your job, have a go at that. Can I ask you to pause the screencast now, please? And then from there, I'm going to go through the mark scheme so you can see it in front of your eyes. So going on from there then, if we have a look, so what we've got. So as you can see on here, you've got the mark here if you wanted to use it for just basic diffusion. I'm not sure you'd always get that. And then if I said down to here, what I've done is labelled the bits that I have taught you. So from here, dissociation curve moves to the right. Okay, so the oxygen dissociation curve or oxyhemoglobin dissociation curve moves to the right. Then I've gone down 0.1 here because of an increase in blood temperature is what I taught you. Okay, so I prefer you to go blood. You can have blood and muscle, but I like blood best. Then if you go down to 0.2, which is what I taught you, there's an increase in the acidity of the blood. I want you to put blood there, so can you please make sure you put acidity of the blood? And then on top of that, there is an increase in carbon dioxide. There's a higher pp CO2 in the muscle, which causes an steeper CO2 diffusion gradient, which causes more carbon dioxide to diffuse from the muscles to the blood. They haven't put much detail. This is a very old mark scheme. And then on top of that, there's a lot more detail on oxygen diffusion gradients. So I think you would get away with talking about the oxygen diffusion gradient here. Is steeper, causing more oxygen to diffuse in. If you felt insecure about that in the exam, you could say where it is higher, where it is low, where it's lower, and where it's high, and then do your diffusion gradients from there. So I'll give you a chance to have a look through that now. Last one to have a look at is the other way that an oxyhemoglobin dissociation question could be asked. So if I put this on here now, so I'm going to put that now. I'm going to ask you to pause. I'm not giving you any help on this one. So read it, pause it, any notes you want to make, and then answer it. And I'm going to put the answer on there now and let you have a look through that yourself to see how you will get marks for it. Okay, so I'm not going to talk through that one because I'll talk through it a little bit more on the other one. Okay, thank you very much.